Hello guys, welcome back to our YouTube channel. This video is about the basics of graphs from motion in a straight line. We are going to discuss three types of graphs: xt graphs, vt graphs and at graphs. Xt graph is displacement versus time, vt graph is velocity versus time, and at graph is acceleration versus time. We are going to look at three cases. One is the body is at rest, next is the body is at uniform motion, and next is the body is in constant acceleration. So let us go to the body at rest at first. The xt graph for a body at rest would be this. The obvious reason is that in the situation of rest, the body does not change its position with time, so its position remains the same. So since its position remains the same, it will have zero velocity and have zero acceleration, so both the vt and the at graphs will be lines like this. Next, about uniform motion, we say a body is in uniform motion when its velocity is constant with time. So let's plot the easiest graph, that is a vt graph. The velocity will be constant with time. Now since velocity is a constant and it's positive, the displacement goes on increasing with time. So either it can be a graph that goes like this if the body has a position at the start, or if it starts from the origin, it will be a graph that's going like this. And the at graph will be same as that for rest, because the acceleration of the body does not change because its velocity is constant. And we know that acceleration is a change in the velocity divided by the time. Next, let us look at the case of constant acceleration. Let's look at the at graph first. It will be a straight line like this. The vt graph of such a body will be like this if it has an initial velocity, and the xt graph for such a body will be of this shape. This shape is a parabola. How do we get that it's a parabola? Because we know the equation x is equal to ut plus half at square, and this applies when the acceleration is constant. So we can say that this graph is a parabola. So this is the three cases. Now let's proceed further. Here are four xt graphs, and what we need to do is we need to tell the sign of velocity and acceleration. The important thing is that the slope of the xt graphs gives the velocity. That we need to keep in mind, and then we can do all of these. So let's look at the first graph. We look at the slope of the graph. Initially the slope is like this, and later the slope becomes like this. In both cases the slope is positive. That means the velocity in this case is positive. But what about the acceleration? Since the slope is increasing, means the velocity is increasing, and velocity is increasing means acceleration also is positive. In the second graph, if you draw the slopes, initially the slope is greater and then it becomes lesser. But in both cases the slope is positive. So velocity is positive in this case, but acceleration, since the velocity is decreasing, is negative. In the next case, if we draw the slopes, we find initially the slope is like this and it becomes like this. Now in both cases the slope is downwards, and so velocity will be negative. And since the downward slope increases, means you can say that the acceleration also is negative. Means it increases the velocity in the negative direction. In the fourth graph, if we draw the slope, we find initially it has a more negative value and later it becomes less negative. But in both cases velocity is negative. Now since it has gone from a more negative value to a less negative value, means the acceleration in this case will be positive. Hope all of you understood this. Now let's do the same for some vt graphs. In this case, we will be finding the sign of acceleration and whether the acceleration itself is increasing or decreasing, because all these are cases of non-uniform acceleration. Let us look at the first case. Over here, it's important to remember that the slope of the vt graph will give us acceleration and the area of the vt graph gives us displacement. So first graph, the slope increases. In both cases, the slope is positive, so acceleration is positive. And since the slope is increasing, means the acceleration is increasing. In the second case, in both cases the slope is positive, and since the slope is decreasing, means the acceleration also is decreasing. In this case, if you draw the slope in both the cases, it's a downward slope, means acceleration is negative, and since the downward slope is increasing, the acceleration is increasing in the negative direction. And over here, if we draw the slopes, we find it's negative in both the cases, means the acceleration is negative, and because the slope is decreasing, we can say that the acceleration is decreasing but in the negative direction. Hope all of you have understood whatever is done till now. We come to the last topic of this video, that is invalid graphs. There are a few general cases of invalid graph which I am going to explain with examples. The first case is a body can't have two values of displacement and velocity at the same time. Let me draw two graphs that are invalid. An xt graph of this sort would be invalid. Why? Because at this particular time period, it will have two values of displacement, which is not possible that it has two displacements at a single time. And a vt graph of this sort also would be invalid, because at the same time it has two different velocities. The next is speed and distance both cannot be negative. I have used a symbol S for speed over here. A graph of this sort that shows speed to be going negative would be invalid, because we know that speed is always a magnitude. We take the absolute value, it can never be negative, and same for distance as well. Distance can never decrease. Even if we turn and go in the opposite direction, displacement that decreases, distance always increases. So if you get a graph of this sort, where I am using the symbol D for distance, if you get a graph of this sort that shows the distance to be decreasing, even though it's not negative, it will be invalid. The slope of xt or vt graph cannot be infinity. Now, if we draw an xt graph like this, then the slope of this graph is infinity. What's the meaning of this? The velocity is infinity, and that's not practically possible. So this graph also would be invalid, and same for a vt graph as well. In that case, infinite slope would mean infinite acceleration. So these are the four basic cases of invalid graphs. There could be other cases as well. It's a very commonly asked question, identify the invalid graphs. And hope all of you have understood whatever is taught in this video, and it help you a lot to solve many questions related to graphs. And please do like this video and recommend it to your friends.
Please do like and share the video and subscribe to our channel.